So I think it was Dumbledore that said the best place to start is right now. Didn't look that one up. May have imagined it. But got this casting and I set it up and I thought, gee, probably should make a video on this because I don't know if someone's going to grab this and going to think, where on earth do I start with this? So, might be of interest. So, the instructions say, and we'll have a look at what the instructions are and what this is and everything else in a minute, but the instructions say to set this up and machine this down, this lip here, down to 1/4 inch is a reference. Looking at this, we're going to set it up and then we're going to, from here, this surface, we're going to machine this boss to fit nicely. And then we're going to set up and ball this the other way around once it's done. So this is just a reference surface, so it doesn't really matter where it is concentrically, I guess. That's my thoughts. So I've just set it up and I've lined this up, and probably just a parallel or a straight edge or something like that against here was plenty good enough. I did check it with an indicator and found it's all over the place. It's very difficult because this is rough casting to actually get it accurate, but what I have done is got it pretty reasonable. And this surface here on the casting seems pretty square and straight, so I've set it up on the jaws here for a start and then checked that, and I've started machining it. So it machines reasonably well, nice and smooth, good casting. This is from Petrie at the Trades Guild. Anyway, let's get this down to 1/4 inch, take it out, take it over the bench and have a bit of a look at it, because it's probably going to be a series of videos if anyone sticks that long. Let's start the lathe. My lathe is a bit untidy and a bit ratty at the moment. It's just going back together, there's still bits moving and need to be sorted out. And hopefully it doesn't sort of make up too much of the noise. So it's running pretty nice there. I'm managing to take about 0.2 of a millimetre, something like that off there. Which is probably cleaner. So looking at this is not really another project. We've still got projects we're working on. We're back in messing around with this, which is about the last project I did on YouTube without being before I got totally discouraged with making videos. But this has come together fairly nice. I've done a bit of work on this. There won't be an actual video on this and people will be disappointed, but I'd like to get it finished. So we've got the crank in. We've sorted out this problem we had with the gland the wrong way around. We've machined the base and put the standard on there, a little oil hole in there. It's coming up all right. They're not bad castings, a Stuart Turner. We'll have another look at it next video and see how much more I've got done. This is a project I thought I'd get in and do something about. It's kicking around. The history of this is that the boys up at Steaming on the Downs, which is a Toowoomba-based steam society, I've done a set of patterns for, I've only got a crappy photograph, but Larry Kazak's Rider Erricson hot air pumping engine. This is a photocopy out of the book. I have book 1, no, I've got book 2. I couldn't find book 1. I believe I have it somewhere. I may have lent it to someone, but I do have a photocopy and we've got a PDF. So we've got the castings, and looking at it, this is the cylinder. This is basically the set of castings. We've got the cylinder, and we've got a base. Pretty much bolts on there, something like that. This base should have some nice ornate legs on it. There's a firebox that goes underneath it. So looking at it, it's quite a big thing. That bolt's on there. This is the standard here. There's more. Wait, there's more. This goes on here. This one goes on here. I've got this in frame. I've got it in frame now. This one goes in here somewhere. This casting I'm going to have to redo, or get someone to redo, because this one's a bit rough, to be honest. And there's a flywheel, which I've already done. Now, this is too big for my machine. I took the opportunity to do this at work, so there was no video, but it's quite a nice flywheel. It's got a 3-inch dowel pin, which I've actually pressed into the right distance here. By press fit, I mean retained with some Loctite, because I had some problems boring this to the size. It's very, very close, but after a day sitting in the sun and getting home and trying the pin, it was no longer as accurate as I thought it was. So we've got it. It's was a tight push fit. You get your thumb on it and push it through. So we fixed that, and there's a fake shaft on here which I've done as well. If we can see that, with a key in it, which is a dummy, which makes it look like that crank goes all the way through. So that goes on here, something like this. It's a fairly big engine. We'll see how we go with it. I'm not promising that I'll ever get it finished, but we might make a start on it. Anyway, flywheel's pretty well nice. What I did find was that this side boss of the flywheel doesn't exactly line up with the other side. They're offset a little bit in the pattern. That's a casting problem with a lot of cast flywheels. This one's very nice. So I've used that as the outside, and basically I machined the boss on this, and I've just hit this with a Dremel and a little carbide burr to clean it up and bring it all back in line. That's a common problem with all cast flywheels, is that if you have a look, the split pattern's a little bit off centre on this side. So I've made this one the outside, and it's all nice and true. And this one here, I've just machined a boss down here, and I've hit it with a Dremel and cleaned it all up. My fingernails are black. Sorry guys. So that's pretty nice. That's done. And I'm not sure this is probably the starting place according to the instructions. I think this should be, but I haven't got any way of holding this on the mill until hold down clamp kit comes from China. So that'll be here this week sometime, and then we'll dress that up and have a look at that. Anyway, back to the cylinder. There's pretty good instructions. It's American design, so really it's fantastic as far as it's been well thought through, and it's got some good ideas, like the dowel pin for the crankshaft with the dummy end. It's a very smart idea, and that sort of copies all the way through. This cylinder is reasonably straightforward. There's also, that's the legs basically that we will have next video. But instructions for the cylinder say it's machine next, which is not really the starting point, but the top is faced off to the 1/4 inch start dimension, which we've done, which is this one here. Then turn around and rechuck, so the bottom flange can be machined to 2 inch inside diameter, and so this board here at 2 inches, 2.28 on the outside. So basically what we're doing at this point is machining this flat. We've got a reference surface here now, so we're going to machine this flat, set this up nice and true, ball this to 2 inches. Looking at it, it's got to have 1/8 of an inch or something like that. There's a fair bit of meat in it, so ball that to 2 inches, machine the outside to the flange size, and then we turn it round and we set it up. Honestly, I got no idea how we set it up, but I think we're just going to grab it in the 3 drawer and hope it's somewhere near. We're not going to be like that, but then we've got to bore this one here and bore this down in here. I don't know if you can see that. There's another gap in there. We can't put my hand in there, but there's a gap down in there. that needs to be machined for the sleeve as well. So then we've got to machine these, and we've got to put eight bolts around here. So it should be straightforward enough to do. It's a nice casting so far. We've got a reasonable start here. This has basically has this bolt on it. Anyway, enough talk. Let's set this up again, this way round, and start machining the bottom here. So I've set this up again. The easiest way was to, I don't know if you can see that, probably not really from that angle. Have a look when I get back over the bench. But what I've done is just super glued a couple of bits of brass here and here, because this flange is really in the way. You can see that flange there won't fit between the jaws on this chuck. If the chuck was, I think probably a 4-jaw chuck, it's the same distance across here on that diameter, and it won't fit here. So I've just put a couple of bits of brass on there to jack this out, and that made it easier to set it up on this, or quite easy to set up on this diameter. Now I've got this running pretty true on this face here. I'm going to move the camera. Got this running pretty true on this face. You see those 2 bits of brass there, but I've got this running pretty true on this face, and on this inside bore. Now, it's a casting. It's within, seriously, if it's within 10 thou, it's probably close enough, but it's not far out. This wants to run pretty true, I think. There's plenty in here to clean this up. We've got to clean this up. So this outside diameter is first, I think. 3¼ inches, and then the distance from, I'm going to give that a tap too and have a bit of a play with it, but the distance from this gap here, this face here, to this face is the next critical one. We'll clean that. I'm going to machine this and this, and then come back and we'll set up and we'll do the bore and this little step on here. So let's go. So I've gone ahead and machined this down. It's only just cleaned up. In fact, it hasn't quite cleaned up. It's about 20 thou under this diameter. I don't think it's going to matter very much. It means that probably my PCD of the bolt holes is going to be a fraction different, but not a big deal. I've put a step in this because measuring this to the final diameter is a bit difficult. I'll measure that separately, but this is the critical one. Here to here is 6¼ inches, I think. I don't know how critical it actually is, but so we've got a bit of a dilemma. How do we measure this distance here between this flange and the back corner here? This is up against the chuck. I haven't got a depth gauge or a depth micrometer that long. So I've got my matrix gauge block holder set out, which gives us a distance from here to here. We know this is 800 thou, this anvil, and it needs to be 6¼ inches. So we've set this up to be basically 6¼ from here to here. See how that works? It's just a frame that holds all those in place. It's probably not a bad idea to just triple check that with a ruler. 6¼ it looks like, but the maths works out, so it should be right. And we've got basically a depth gauge that will tell us exactly, if you like, a go/no-go gauge, and we set this up against the chuck. When this fits over the top, we'll know exactly where we are. So let's go and have a look and do that. For anyone who's interested, there's the rest of the kit. This is a pretty useful thing. It's got a short holder, a long holder. It's also got a gauge box stand, a depth gauge stand. So you can set any of these up as a depth gauge. And it's got a set of different centres. It's got centres and scribing blocks, half rounds, other things that your average height gauge hasn't got. Different radius half rounds. and measures the inside of the cylinder. Anyway, a fairly useful thing. It's made by Matrix in England. I'm sure they're available from other makers, but it goes out to about longer than the gauge blocks I've got. This one goes out to about 12 inches. I don't think I've got 12 inches of gauge blocks, but anyway, something you use. I use this instead of a height gauge because honestly it's more compact, it's simpler, it's more reliable. You don't get a parallax issue that you get with the old height gauge I had, and it's compact, it's in a little box. It's excellent. If you see one, pick one up. So here we go. We slide this down the chuck here. It's still a fraction wide, and that's what we sort of calculated it out at. I'm going to take another cut off at another 0.1 of a millimetre and see if that fits. Right, I think that's going to do nicely. Now, we've got that machined, we've got to get this length down, and we've got to get this to size, and we've got to face the back of it a bit. So I'm going to get this down. We'll have a look at cleaning this back up before we bore it. Anyway, I've got this right, and I've just set up and just kissed this on the right PCD for the bolt holes. So I set that with a 45-degree angle tool and just measured that in from the outside edge and got that right, or what I think's right, what looks right, and what the measurement looks like it should be. Probably going to break this edge with the same tool. This one I've already done. And then I think before I face the back edge here, I'm going to bore it. So we'll set up a boring bar and see if we can. It's going to take a minute to get that right and right through, and bore it all the way through at 2 inches. See how that goes. So anyway, I bored that, and I'm measuring this. We're 50.77 or something both ends, which is about where I'd like to be. I'm going to run a hone through that probably and take a fraction more out, but it's not a real critical dimension. You've got to remember that it's got to be as close as you can get it, but it is just a displacer cylinder, so there's nothing actually runs in this. It's got an air gap around it, so smooth's probably more important than exact, but it won't be far out. So we've got that. That's looking pretty good. If you see these come up cheap, let me know and I'll buy them. I'd say there's not enough of them come up cheap to buy them yourself, and there's not a lot of them come up cheap, I mean, you miss out. So we got 20, 23 there on the reading, and 23 there on the reading. That's pretty good, but they're an awesome thing. This one's oh my gosh, it comes in a box, can't tell you what brand it is. It should be written on here. It's England. It's Bowers, which is basically more than right. Very nice thing. This one's 37 to 51, which is a useful size. I've only got a couple. Some bigger ones would be nice, but they're out of my price range right now. Anyway, that's pretty good. The only real job to do on this end is to clean that up. So another tool, I guess, what we're probably going to do is we're going to set up and use this round nose tool. Clean this up in here. Should go in there and clean up nicely. We'll see how it goes. We'll set that up now and come back and have a look at it. So that's starting to clean up there. It's still got a few hollow spots done there. But you can't see that on that camera angle, but there's a bit there. It's got to come down to 2.22 of an inch, so it's a fair bit. see what happens. Now I'll tell you exactly what happens, because it's going to make you seasick, because the harmonics on that are not real good. Getting a lot closer. Right, so we've got this dimension right, and we've got this cleaned up pretty nice here. We've got this dimension right from here to here, and we've got this dimension right from here to here. We've got this board pretty good, and we've got this dimension right, and this dimension's a bit under, but it won't hurt. So I'm going to break that edge there nicely, just carefully, and take it out, and we'll have a look at what needs to be done next over at the bench.